Okay. Quadratic functions. So, ladies and gentlemen, I need to call your minds to the following. Graph paper. Where's my graph paper? Where's my graph paper? Where's my graph paper? There it is. You are all already familiar with this. Right? That is a linear function. If I were to ask you to graph it, you would all immediately be able to do so because, of course, you would get a Cartesian plane, and you would, of course, remember that that is the y-intercept. Y equals 9. That is the slope, which is, of course, 2 rise and 3 run. Since they are both positive, you go up and right. So you would go up to 1, 2, 3, 4, 5, 6, 7, 8, 9. And since you can't go off the graph, you would go down 2 and left 3, down 2 and left 3, down 2 and left 3, and you would draw that line. Yes? All of you know that already in your sleep, upside down, backwards, holding your breath, underwater, in Sanskrit. You all know that well, right? Let's pretend you don't remember that. You do, of course, know you could make a table of values, right? And you remember that this is simply another way of writing y, the f of x, right? Spectacular. So you will notice that in this unit, I am still using that notation. But there is a difference. The functions look different. What is different? This is a linear function, f of x equals 3x plus 9. That is linear. We are now doing quadratics. A quadratic function looks like this. What's the difference? Don't say one's a binomial and one's a trinomial. Because, actually, I will give you another. This is a quadratic function. What's the difference? He waited patiently. Thank you. There is a squared. There's an exponent there. To be quadratic, it is squared. Now, Hayden was also making a joker face because this graphs as a straight line. This graphs as a U. Okay? We are dealing with this, but you can't deal with this if you don't know the properties of this. Yeah? Okay. Now, you can see, look at how many new pieces of vocabulary and things you're going to need to be able to deal with in this unit. You're going to have to graph. You're going to have to find the vertex. You're going to have to find intercepts, axis of symmetry. I'm going to change colors there and ask your opinions of a few things. Yellow, blue, green, and pink. Which of those colors, yellow, blue, green, and pink, do you already know how to, or have already dealt with? You have dealt with graphing, and you have dealt with the green, x and y intercepts, yes? But the blue and the pink are going to be new to you. All righty then. Let us move along. And as always, I like to start a unit with what you already know how to do. Okay? So let's do so. First of all, can somebody tell me what makes something an equation? It has to equal something. So I'm going to write something up here, and you're going to tell me if you can solve it or not, okay? Is that soluble? Which is what you actually mean when you say solvable, that people have changed that word. Why not, Jacob? It doesn't equal anything. What is the only thing you can do with that? Factor it. You can simplify that because that is an expression. What would you do to simplify that?
You would factor it.
You would factor it to what? 4 and 3. So what would it look like? X plus 4, x plus 3. Yeah? Everyone agrees? Ease, bees, lemon squeezy, yes? Well, to make it an equation, it would have to equal something. And this is what we did at the very end of radical equations, yes? Now that equals 0. So now what do we know? X has to equal either -4 or -3. Yes? Now, in radical equations, we had to square to get rid of a root, didn't we? Which means there is a possibility of extraneous roots. Yes? Did I square anything here? No, I did not. So are either of those extraneous? No. And if you check them, you will indeed find that they are not. What is -4 squared plus 7 times -4 plus 12? What is -4 squared? Positive 16. What is 7 times -4? -28 plus 12. Does that equal 0? Yes, it does, because 16 plus 12 is positive 28. That's -28, right? So -4 works. Does -3? -3 squared plus 7 times -3 plus 12 equals 0. 21 minus, sorry, not 21, you idiot, 9 minus 21 plus 12. Does that still work? Yes. So there are no extraneous roots because we never squared anything, yes? Everybody cool? Ease, peas, lemon squeezy, right? These answers are what we call the roots of the equation. And these answers, and I'm going to add a third color here. I'm feeling orange today. They are the x-intercepts. Now, if they are x-intercepts, that must mean they can live on a graph, yes? On a graph, every single point has how many numbers to define it? 2. One of them is an x value, one of them is a y value, yes? So since we are going to be graphing this unit, what do these two numbers become when I put them on a graph? He waited patiently. Here is a graph. I am telling you that the x-intercepts are -4 and -3. Where would they live on this graph? On the left. -4, -3, right? But they are not just -4 and -3. What are they? Right. -4, 0, and -3, 0. Right? Because in this function, that's our output. Is everybody good? We all remember this from the ninth. From the 10th grade? Excellent. That's next. This is the first way to solve quadratic equations. Okay? This is the first way to do it, and you already know it. A times B equals 0. If this is true, then what do we know about A and B? What do we know? Guneet. We know that they would be intercepts if it was a quadratic formula, yes? But I'm just talking in general terms. Something times something else equals 0. What do I know about A and B?
One of them has to be.
Right. A or B must equal 0. No matter what they look like. Does everyone understand that? What do I mean by no matter what they look like? Well, if I had x and x minus 7, what do I know about this situation? Ashton?
X can neither be 7 or 0.
X must equal 0. Or, and this is key, the or, x minus 7 must equal 0, which would mean x must equal 7. Everybody good? Yeah? Now, since we're only doing quadratics, it's only going to have two options. Next year, you'll be doing cubes. And the graphs will not be a smiley face, they will be a wave. All right? Everybody good? But for our purposes, this is what we're dealing with now. Now, have we ever seen functions that we cannot get to this form? Yeah, we have. What if I gave you this? I should change color. X squared plus 7x plus 1. Will that get to this form? No. So we're going to need further tools, aren't we? But like always, I start with the easiest one that applies to what you already know. Okay? Everybody cool? All right. So turn your page over, and you will see 3 of these. If they're in blue, I work them with you. So this first one, I look at it, I see that it is a function, I see that it is a trinomial, I see it equals 0, which means I can come up with an answer. And that answer would be, I would need to multiply to negative 14 and add to negative 5. What are they?
Negative 7 and 2.
X plus 2, x minus 7 equals 0, which then leads me to 2 different paths. Either x plus 2 equals 0 or x minus 7 equals 0. So x equals negative 2 or x equals 7. Now, do you need to write the 2 and the or the or? No, it is perfectly valid to say x equals negative 2, comma 7. All right? I don't like starting with that because that looks like coordinates on a graph, doesn't it? And some of you will say, oh, I got to put a dot at negative 2, 7. Would you? No. So maybe actually in my notes, I'm going to leave that or, but I'm going to stop the triple underline. Everybody cool? X is that or that, and they are only x values. What are they on the graph? As coordinates, negative 2, 0, or 7, 0. Right? Okay, let's look at the next one. Quadratic function, how do you know? It's got a squared. Once it has a squared, we know it has how many possible answers? 2, and it equals 0, so we can find the answer. What do I have to multiply to? Negative 15. And what do I have to add to? 2. What is it?
Negative 3.
Right. So it is x plus 5 over 3 and x minus 2 over 3, correct? Now, if we were simplifying for factoring, what would we do with those denominators? We'd slide them to the front, wouldn't we? But are we factoring here, or are we trying to seek an answer? We're trying to seek an answer. Now notice, when I got to here, when they were whole numbers, the answer just switched the sign, right? So can I do the same thing here? Oh, sorry, that's supposed to be 3. 3 minus, right? Which would simplify to 1. Now, here, does that look like the yellow? So can I stop with, do I have to slide that denominator? No. So what is x? Negative 5/3 and positive 1. Right? And if we checked it, we would indeed find it. So let's do our third one. What must I multiply to? 4. What must I add to? What is it? So it is x plus 2 over 4. X plus 2 over 4. Simplify to 1/2. Simplify to 1/2. And now we're in an interesting situation because they're the same. So what is the only thing x can be? Negative 1/2. Why no or? Because it's x plus 1/2 squared. It's the exact same thing twice. Everybody cool? I'm going to show you right now, even though we're not graphing yet. This red one would look like this. Negative 2, positive 7. It would look like that. This blue one, negative 5/3. A little bit past 2 and 1. It would look like that. This green one, how many times does this green one hit the x-axis? Once at negative 1/2. There's negative 1. There is negative 1/2, yes? So it would look like this. It would bounce off. We'll come to that, but there's no point graphing if you don't understand the algebra. Everybody good? Yeah? Do those 6. Go. Yeah? Yeah? Nothing new. We're just factoring, right? I'm not going to force you to learn what I'm about to show you next, but I want you to understand. Yes? What do you mean? You were asking me. Say it again? No, Jacob, don't do that. So D was... So you mean if it was something like this? Oh, that would be a cubic. That would graph like this. And you won't be doing that till next year. Okay? We will only ever be dealing with squares. That's what makes a quadratic. Has to have a squared with the independent variable. All right, so A would look like this in a graph. 2 and 1, because they're both positive, right? You don't have to learn this. We're going to learn why soon. I just want you to start getting it in your head. B, one's negative, one's positive. So it's going to look like that, right? What would C look like? Tall and skinny. Wide, what would C look like? Tall and skinny, because it's 6 and 5, right? Both positive. What would D look like? Plus and minus 5. Chubby, to use Jacob's words. 6 and negative 8. Again, 6, negative 8. And F, what would F look like? Would it go below? No, it would bounce off at negative 3. Everybody good? We'll talk about what this line will really look like later, but I'm trying to stress that the answers we are finding are those intercepts. Everybody cool? Because it's x equals or b equals. These are obviously the independent variable, yes? Okay, so these next 6 are harder. Why? Because they're that kind of factoring that most of you have trouble with. Factor those, figure it out. It will take a little bit longer. When you are done factoring them, try to just show me what the graph would look like. Everybody cool? No numbers on it, but if they're both negative, it's going to be on the left of the y-axis, right? Just like that. Everybody good? Go. Yes, Allie.
Can I go to 11?
Of course you can. Sure. Is everybody cool? It's nothing new. We're just factoring, right? Yeah, no, I know. But you're just factoring, yeah? I don't mean to stop. I keep factoring. But there it all is, right? So you finish up your factoring. No rush. I'm just... Damn, that was funny! Whatever, Jacob.